Hi, I'm an old guy and I do maths. And today we're looking at the idea of depreciation. So we're in financial maths, um, which you should realize because hopefully you came here via the playlist, which says financial mathematics. Now, what is depreciation? Well, depreciation is something that you have to get your head around if you do finance or financial maths or accounting, any of those. Um, In some aspects, it is similar to decay. So, those of you who do physics or chemistry might then have an idea of what I'm talking about. Um, but this is financial maths because of the use of the word depreciation, which is the term used there. Right, what is it? Um, well, it is a means by which the value of an asset is decreased over time as it wears out or ages. So, an example. Um, People are probably familiar with the example of a car, which, if you buy it brand new and drive it off the dealer's lot, because it's no longer new, it's usually worth less. Um, Now, that's the idea. But the question is, how do we how do we calculate it, and what are the various types of depreciation? So in this video, we're going to look at the various types, and then there will be separate videos on how each of them works. Okay, so the first type is sometimes referred to as flat rate or straight line. I'll add flat rate here. And how this works is it takes the initial value of the asset, which we'll say is $1,000, and every allocated period, whether that's a year or 6 months or a month or whatever, the value of this is decreased by a set amount. Now, that set amount might be $100. So after 10 years, 10 lots of $100 will have been taken off the value of this, and so it will have what's called a residual value or a scrap value of 0. Those are all what you might call terms of art. Don't worry about trying to remember those. They'll be dealt with, as I said, in individual videos. But the main idea here is that a flat rate of depreciation or straight line depreciation can be represented by a linear graph that goes like that, with your starting value here, so this would be 1,000, and every year $100 is taken off the value of that. So it can also be represented as a linear equation. Now, one other thing to say about this: it may not be expressed in dollar terms. This number here might not be expressed in dollar terms. So it might be that you're told to take 10% off of this price off this each year. As it happens, 10% is equal to $100 in this case. So that's flat rate. It is the same amount taken off the value of an asset every year or every period, whatever you want to call it. Now, the next one that you will come across is reducing balance. And for the physicists and chemists amongst you, this is the decay that you're familiar with. And it's normally expressed in financial terms as a percentage. And let's take our $1,000 asset again and say that every year 10% is going to be taken off the value of this. Well, you ask, what's the difference between what I just said and this? Well, this 10% is 10% of that always. So it's $100 every time. This one is 10% of the reducing value of this asset. So if in the first year it is $1,000, we subtract 100, and that gives us $900. The next time that we calculate the depreciation on this, it is going to be $900 times 10%. So we're going to subtract 90, and that's going to leave us 810, and so forth and so on. I don't want to get too far into this, but that's the basic idea. And the graph of this looks like that. It's got a curve. And again, people who've played around with decay in physics or chemistry, or those of you who've worked in statistics with declining populations, that sort of thing, this will be familiar. Okay. Now, again, how it differs from up here is that this 10% is $100 always. It's 10% of the purchase price. This 10% is 10% of the current value of the asset, whatever that is. Right, one more thing. Unit cost. Now, this is used in cases usually like machinery that has a productive lifetime, and that productive lifetime is usually expressed in units. So, imagine a $1,000 printer. Maybe it's a 3D printer, and it's got a life of it's got a productive life. It always prints the same thing. That's important too, but it's got a productive life of, let's say, 10,000 units, and it cost $1,000. And at the end of its life, it's going to be worth, let's make it easy. Let's just say it's going to be worth nothing. So this is the purchase price. This is what it's going to be worth at the end of its life after it's produced 10,000 units. Now, the fundamental difference between unit cost depreciation and these other forms of depreciation is that this is calculated in units of production, not time. So it might take 10 years to produce 10,000 units. It might take 1 year. That doesn't matter. The depreciation is calculated according to the number of units that are produced. And in order to do that, what you have to do is you have to calculate what's called a unit cost, which is simply this value here, 10,000, divided into the difference between these two values. So I made this nice and easy. It's 10,000 divided into 1,000. So it's a matter of some sense. It's very, very easy to calculate. And then all you have to do is keep a track of how many units are produced. And let's just say that there are 500. Get this straight. 500 units are produced in a year. So the depreciation on this will be 500 times 1,000 divided by 10,000, which is that's the unit cost. The number of units divided into that, and we have 5,000 of them. 500 of them, rather. Okay, so those are the basic ideas. Let me run through this again quickly. We have straight line or flat rate depreciation, which is the same amount taken off the value of an asset every year, let's say. We have reducing balance, which also looks like loans. They're calculated the same way, reducing balance loans. And a percentage of the current value of the asset is deducted each year. So again, $1,000, it's $100, $900 in the next year, so it's $90 and so forth and so on. Then we have unit cost, which is often just applied to machinery, and it takes account of the fact that the machinery has a certain productive life which is expressed in units, not time. Well, I hope this wasn't too confusing. There's going to be a video on each of these with examples in the playlist, and I suggest that if you want to get further into this, you have a look at those. Thanks very much for watching. See you next time.